Okay, this topic is really the guts of integration. In the notes, the title is Integration by Substitution. A lot of the time I don't do that. Makes it a wee bit easier if you don't think of substitution all the time. Right, let me explain to you what substitution is. So the first example. When you're doing it by substitution, this is the awkward bit. So they say, let u equal the awkward bit. Okay? Now, I want a dx. So I'm going to substitute it all in. I get a dx by differentiating u. If you differentiate that, you get 2. Then if you're allowed to rearrange that. So dx is du over 2. So I take my integral now. 2x add 1 is u. Dx is now du over 2. So it's a half u5 du. All in terms of u's, I can integrate. So you add 1 to the power and divide by it. So you've got a half, whoops, and then a 6. Should have the integral sign in once I've integrated it. So it's u6 over 12. And don't forget to put your u back in. So that's substitution. Okay? Can be quite long. So what way would I use? I've called it reverse brackets. Now, let's go back to differentiating a bracket. Do you remember when you differentiate a bracket? You had to have, you brought the power to the front, you took one off, and then you put the derivative of the bracket in front. Well, to integrate a bracket, you add 1 to the power, you divide by it, but you must have the derivative in front before any integration. So that's like the key I would talk about if I was saying you the key to unlocking this. If you look at this, the derivative of this is 2. So I'm going to put a 2 in front. Because I just randomly put that 2 in there, I balance it outside with a half. Now, that half just sits there. Do you see this bit inside the integral sign? I can treat that as a bracket because I have the derivative in. So you add 1 to the power, divide by it, and don't forget your c, tidying it all up. So you can see the way that is a lot quicker than using substitution. Example 2. Again, I just want to run through these because I know these are tricky. I find it quite hard looking at that and not wanting to do the bracket way because I'm so used to it. But anyway, I'll go through the substitution with you. So let u equal the awkward bit. So du by dx, differentiate that, you get minus 3. Rearrange that to get dx on its own. Remember that's multiplying, so it comes over to be a division. Take your integral sign. That is your u, so u6. Dx is du over negative 3. Okay, so it's u6 over negative 3 du. Add 1 to the power and divide by it. Don't forget your c. So it's u7 over minus 21, add c, and put your u back in the end. 5 minus 3x to the 7 over minus 21, add c. I just find that very long. Anyway, this is the way I would do that. So 5 minus 3x, 6 dx. It's a bracket. So what's the key? The key is to have the derivative in front. You must have the derivative in front. So the key is the derivative in front. So what is the derivative of that? It's a minus 3. So I'm popping in a minus 3. Because I randomly put in a minus 3, I've got to balance it outside by a third. Because in fact I haven't changed the question, because that gives you plus 1. So the middle bit's ready to go. Let that minus a third sit outside. You've got the derivative, that's your key, you're good to go. Add 1 to the power, divide by it, and don't forget your c. Now I know it's quite hard and I'm flitting between the two methods, but to say, I would always use the bracket one. Right, we shall look at this next one here. 1 over 2x minus 3 cubed dx. Can't do anything in the bottom row, bring it up. Now, I'm not going to do substitution in this one because to me it's much easier doing the bracket. So what's the key? The key is the derivative in front. So the derivative of that's a 2. But remember, you need to balance. Half outside. So now you're good to go. Add 1 to the power and divide by the new power. Or I should say, whenever you differentiate, the derivative disappears. So it's 2x minus 3 minus 2 all over minus 4 plus c. Okay, let's try another one. So it's 1 over root 3 4x minus 1 dx. So I would write that as power of a third. So it comes up to the top line minus the third. To integrate, the key is a derivative.